Okay, so real quick, my name is Eric Semmer. I'm the CEO and founder here at Decodable. I'm going to talk about real-time change data capture data and not just replication, but like I said, some processing of that data so that you can ingest it into various database systems, both operational, but also analytical database systems and even event-driven microservices. So just to sort of set the stage, first, what exactly is CDC data or change data capture data? Most people know this, but just at a high level, it's really just a stream of operations that were performed to one or more tables in a database system. And actually comes from the database native implementation of the write-ahead log, or the replication log, the bin log. Different database systems call these things different things, but that's where change data capture data winds up coming from. And we actually internally wind up using the Debezium representation of CDC data. Debezium is an open source project that we use under the hood inside of Decodable to power all of the change data capture functionality that we have. Every CDC system like Debezium, there's systems like HBR, various other commercial offerings, they all have their own formats and semantics and tons of options and configuration that you can tune and tweak on these systems. Debezium is, at least its format, not just the project, but its format is very quickly becoming like a de facto standard that lots of other systems are starting to adopt. So it's really interesting to have a single way of thinking about change data capture data. And so in general, source systems like Postgres or MySQL or Mongo generate these CDC events, and then sync systems or target systems, whatever you want to call them, apply those changes to their own state internally. And so basically that's how it works. And so this is an example, it's a contrived example of what a CDC event winds up looking like under the hood. But basically there's an operation field that contains a single letter that denotes whether it's the event represents like an insert, an update, a delete, so on and so forth. And then it will give you both a before view of the record and an after view of the record. There's a bunch of metadata fields that I've omitted here around that describe the source, like the table name that it came from. And for some systems, excuse me, you can get various attributes from the database system, like the LSN, the log sequence number, or the transaction ID, and sort of various other details about the database system, again, that come from the write-ahead log at the wall. I've omitted them here just for simplicity, but this is what an insert event might look like in Debezium format. So the before doesn't exist, and so it's basically an empty record, and the after would contain like user ID 1 and status active, whereas an update record might contain both the before record, in this case, where user ID 1 was active, and then the after, the result of the update operation, where status has changed to inactive. Okay, so like most people know about CDC data in general. So like, what's the big deal? Well, most people use CDC data for straight up database replication in like ELT or extract, load, transform pipelines, where you're sort of pulling a stream of CDC and then just basically dumping that result into another database system that's applying that set of changes. And that's all well and good. That's like the most common use case that I think we see with CDC data. But you can actually process CDC data in between those two systems to do a lot of very, very cool stuff. I'm going to show you some of that stuff today, as well as a demo. Okay, so what can you do with this? Some of the simplest cases, you can actually treat CDC data in some systems like Decodable, again, I'll show you this in a little bit, as actual records, and be able to process the logical data that the event represents. And that allows you to do things like compute aggregate statistics and derived views or transformed views of that data without actually landing it in a database system to then process it. You can do things like keep caches up to date. So like a super common use case is that you have an operational database, like let's say Postgres, and I'm going to show you our demo today is going to be based on Postgres. You have a demo like Postgres or a database like Postgres, and you have user profile data that's being updated in a table, and you want to create a cached view of active user profiles or updated user profiles in the system like Redis, or maybe some other operational database systems for fast access. You can actually set up a CDC stream that pulls all the updates to the user profile table and then transforms them, maybe rekeys them for rapid lookup, and then routes them to different Redis caches in different cloud regions, for instance. You can also trigger external processes. Maybe an example is whenever somebody updates an email address in the operational database, you want to send a validation email via a service like SendGrid or Amazon SES to validate that email address. Really, really simple stuff. You can actually take the CDC data, filter it for cases where the email address has changed, and then actually create a trigger event, make an API call to one of those systems. We also see a lot of cases where just looping this data through external processes. You can sort of think about this as like an external stored procedure or an external trigger. So you update some records in a database system, and then you use the change data capture stream. You maybe filter or cleanse or transform that data and then push it through an online ML inference system for scoring, and then write the result back into the operational database system or a cache so that you can serve that data in real time back to users. This is really common for like recommender systems, like product recommendations or content recommendation systems, where based on what the user is doing, you actually want to change, the set of recommendations that you want to serve back to them. And so basically, this is how you can do real time, in session recommender systems, just as one use case. If you're an enterprise business, sometimes you just have to provide a feed of activity to partners or customers. CDNs, for instance, content distribution networks, very commonly have to provide things like clickstream data and stuff like that. You can actually use streaming systems and change data capture to like enrich data and then provide that out to your customers. And you can do it all in real time. And I think that that's really interesting because it opens up a whole bunch of new use cases. Okay, so I want to get out of slides and get into actual hands-on demo and sort of show you a little bit of what this looks like in action. So today, I'm actually going to use a Postgres database that I have stood up here. Hopefully, this is big enough for everybody to see. I have a single table called users that has, some pretty standard, very simple schema here. So it has an ID, which is a big int. It's not null. All these fields are not null. Username, email address, status, which we'll use to mimic like an active versus an inactive user, or maybe like a suspended user. So we use that as part of the demo. And some standard timestamp stuff like the time the user was created and the time the user was updated. We have our primary key, which is ID. And what I'm going to do is I'm going to show you how this is actually set up inside of Decodable. So in Decodable, at a very high level, we have connections to source and sync systems. Source is produced to streams, syncs consume from streams, and then pipelines, which are basically SQL queries. Basically, SQL queries process that data in real time. So I have a Postgres connection set up You can see that these things will heal as they bump into problems and stuff like that. Sometimes there's connectivity issues. We've actually been seeing those with the cloud provider that we're showing today. So basically, this Postgres instance is connected to an Aurora cluster. You can see standard port, standard database stuff, and schema. We are subscribed to the users table. We have some username, password, credentials, and the CDC data is being output and encoded using the default PG output encoding plugin, which you can, if you know Postgres, this is probably, pretty common stuff. If you don't know Postgres, this is really just how Postgres decides how to encode events out of the write-ahead log in order to be externalized, from the system. And so I have set up this schema, and what Decodable has done is actually attached to this and replicated what this looks like inside of Decodable. So we have all the same fields, ID, username, email address, status, created and updated timestamps. They have the same data types as in the database, and so basically, this is kind of up and running. You can see that we have no bytes in, no records in, bytes out, records out coming out of this. And this connection is connected to this user raw to stream. And you can see in Decodable, this is a change stream, which means that it's going to implicitly understand CDC events. And we see a preview of the stream. There's no data in it. So it's the world's least exciting stream. And this stream has the same schema as the connection. And that's so multiple pipelines can write to it, multiple pipelines or connections can write to it or read from it. So the stream is sort of the rendezvous point between connections and pipelines. This has no outputs hanging off of it just yet. We're going to create a pipeline in just a minute. And on the table side, if I select star from my users table, you can see there's nothing up my sleeve. There's nothing in this table just yet. So I'm going to actually flip back over to my connection here. And so Decodable will recover from any kind of connectivity errors. You see this happened 3 minutes ago, but we're back up and in a running state now. So that's good. Sometimes connectivity issues, whatever actually happened. So what I'm going to do off screen, I have a couple of SQL statements. So basically I'm just going to copy and paste these so you don't have to watch me type. I'm going to insert a record into this table. And again, my ID, my username, my email address, status is going to be active for this user. And for created and updated, I'm going to set my timestamps to now. So I'm going to insert this. I have auto commit turned on. So, we can see that record got inserted. And if I flip over to Decodable, we can see that this event is actually already streamed into the system by CDC. We see that the record count has increased, so the byte count has increased. And if we flip over to the stream, we'll see the actual record, has come into Decodable. So there's some interesting stuff going on here. One, you see all the same fields, but what we've done is we've identified based on the primary key of this stream. So remember, we've got ID here set to our primary key. And what this does is it actually tells Decodable that any record with the same primary key, subsequent CDC events will actually cause this to be updated in some way. And so just to keep things a little bit interesting, I am going to insert a couple of other records. I'm going to insert 2 other records, same format, just with ID 2 and 3. And then, I've set eSAMR 2 and 3 and my email address, accordingly 2 and 3. So if we insert these and we select star, we now see we have 3 records. They have slightly different timestamps, which is great, but they're all active. And over here, let me just reactivate this preview. You can see that those events streamed in, right? So no big surprise, kind of works as advertised. Excuse me. But now we're going to do some interesting stuff. So what I'm actually going to do is I am going to deactivate one of our users. So basically, I'm going to set status equals inactive, where ID equals 1, right? Really, really simple. I'm going to flip that bit, and I'm going to flip back over to Decodable. This is still streaming. So we see now we get another record where ID is still 1, but status is inactive, right? And so, basically this is going to mimic an update to the system. All well and good. We're just really seeing the stream here, not yet super interesting. So let's do this. Let's create a pipeline off of this. So a pipeline is really just a SQL query inside of Decodable. I'll blow this up just a little bit. So the query is always insert into our output stream, select from our set of input streams. Like if we want to do things like joins and stuff like that, we can do those kinds of things. We can do aggregations. We basically do anything we can normally do inside of a select statement. And so this is kind of the format that we use. I'm going to pop open my users. I'm going to pop open the catalog here, just so I'm going to remind myself, what these look like. So let's, what's a good thing we can do? We can select status, and we're going to count as, well, let's just call this count. We're going to count the number of users by status from our input stream. So I'm going to group by the status. I'm going to get rid of this. We don't need that right now. I'm going to run a preview. And what this is going to do is it's actually going to run this query, but it's going to do it over the change data capture data. And so what you'll notice here is that we actually see for active, we have 2 records. For inactive, we have 1, and we're waiting for more results. So let's actually flip back over to our terminal here. And we're actually going to flip this user back to active. And what we should see here is that this changes. We've basically updated the records, which causes a retraction in stream processing terms, where the previous value for inactive was deleted, was decremented to 0. And the active status was updated to 3, which is what we expect. In fact, if we run the same query here, we can say group by status. We would see the same result. And so the cool thing that's happening here is that we could be materializing these updates and keeping these updates up to date in another database system or in a cache, in sort of various other ways. And so this kind of streaming aggregate, I didn't have to think about processing or applying those changes. The system's doing that for me. So this is really, really interesting, because it means that at any given time, I can be effectively processing these changes as they're being materialized, as they're happening in the production system. So, and again, just to, this previews actually expire after a certain period of time, and you can actually see that it processed 11 changes to 1 record. So that means it's behind the scenes processing all of those changes. And the reason why it's 1 record is because at this point in the stream, there's only one active, there's 1 key. That's our key for this particular query, status. And so the system's smart enough to understand that all of those changes wound up rolling up to 1 final record. I'm actually going to start this again, just so that we can play around with this a little bit more, and just kind of prove to ourselves. So let's actually do this. Let's actually make this user inactive, and let's say that user 2 winds up getting suspended. Before I hit enter, just to sort of show you, this is actually the case. We have now 2 records inactive, or sorry, 2 active, 1 inactive. We update this, and now this is going to update again, where we now have 1 user inactive, 1 active, and 1 suspended. And so again, really, really interesting stuff. We could also, I mean, this is an aggregation, but we could also do some simple processing. What's a good example? Let's do, let's actually split the email address on the @ symbol and take this portion as the, let's call it user domain. Let's get rid of our group by. And we can, oh, did I make a mistake? Split, character. No magical function. Oh, split, sorry. Split index. Oops. Okay, so what this is going to do is it's going to wind up splitting on the @ symbol, and it's going to create basically a record for every user. And in fact, just to sort of prove to ourselves that this is doing the right thing, what I'm actually going to do is I'm going to select user ID. I'll select email address just so that we have it. Oops, ID. And so what this will do is just give me additional columns in this. So this is a sort of example of how we could transform this data, right? So we have all 3 of our users, but just to make this maybe a little bit more interesting, let's actually also aggregate by this. So let's do a select by user domain, and let's do a count. Let's do a count by that from this inner query, and we'll group by user domain, and we'll rerun this. And so now what we should get is a count by the number of email address domains. So for instance, if we go and we update, let's set email to set email to, let's do esammer1@gmail.com, where user ID 2 is fine. Let's do that. So what we should see now is that we split this out and we wind up getting a user for both 2 for decodable.co, 1 for gmail.com. So like, it's pretty obvious, like the kinds of things that you could wind up building on top of this. And we're just previewing this data, but let's actually create this stream. Let's say user domain stats. And so what this is going to do now is that Decodable is going to say, okay, we're going to create a new output stream. It's inferred our output schema. User domain in this case could be potentially up to a varchar 2000. We could tweak this if we want. We're not going to do that right now. It's an inferred stream. Let's just say count of users by email domain. And Decodable is going to allow us to pick the primary key on the output stream now. And so again, just like the input stream, this is going to determine which records get updated. So by picking user domain as our primary key, every time we get a new record with the same user domain, it's going to act as an update or a delete for that key. And so when we create the stream, Decodable is going to create this. It's going to decide that the stream now exists. You'll see that it annotated user domain now as the primary key field. And so now we're naming our pipeline, and we're going to say, we're going to call this user domain counter. And we can create this pipeline. You see, similar to the connection that we had earlier, we have, a certain number of tasks that we can assign. Tasks in Decodable is sort of like how much processing capacity exists for this pipeline. In this case, it's parallel processing capacity. So this is currently set to a maximum of 1 task, and there's 0 running tasks because our pipeline is stopped. You can see that the input is coming from this raw table, and here you can actually see all the changes that we made. So we have sort of the full history of those changes, and that's coming from our users PG connection. But looking again at our new user domain counter pipeline, again, this has our SQL associated with it. There's no input or output records yet. I can start this and specify the number of tasks. This is a really simple pipeline, so I'm going to only use a single task here. Let's start this pipeline, and assuming we don't run out of tasks on our test account, this should fire up in just a sec. Starting pipelines can actually take a second because we're allocating resources and tuning and doing a bunch of stuff behind the scenes. The system sort of like determines how many tasks that we want to use. And you can see now running tasks is now 1. So the system is starting to figure out that something's firing up behind the scenes. And this will stay in the starting state until we actually get all of the tasks running behind the scenes, and we start to see internally that the pipeline's in a healthy state. So it'll actually linger in this state a little bit. You actually will see the record counts start to flow in just a second. I'm going to zoom out a little bit rather than make everybody scroll sick. Oh, started already. So you can see that it's actually already processed 8 records. It's output 13 records. I'm going to show you why in just a sec. So even though we wrote our SQL as if we were just programming against the table, remember that these pipelines are dealing in terms of these CDC events. And so they're actually getting updates, they're getting deletes, they're getting retractions, they're getting all sorts of changes to that. And so that's why you might sometimes see multiple records come out the other side. So in the output of this, which we can look at here, we can actually see what's happening. These are, this timestamp is actually the processing time. So you can see that we have our user domain with a null value. This actually indicates a delete internally within the system. And then it gets updated with a new value to count 1. Then it gets deleted again and gets updated with count 1, and then gets updated to count 2, gets updated to count 1, 2. So like basically it's going through all of the changes that make sense given the input records that were being processed there. So this, I'm going to leave this running, and we'll go back over here, and let's actually update this to decodable.co for user ID 2. So we're basically resetting our email address. And what we should see here is, again, another update and retraction. So here now gmail.com is effectively getting deleted. Decodable.co goes back up to a count of 3. So this is sort of the low level change data capture data. If we actually create a pipeline that just says select star from this, and we run this preview, what we should actually see is not the CDC events, but the result of having applied those CDC events. And so again, let's say we change this back to Gmail, right? We're going to sort of see a change occurred there. We can flip this back to Decodable, and we should see a change there. So basically, able to process all of the events, as you would expect there, in real time. And again, this will allow us to, if we wanted to further transform this pipeline. In this case, though, we could actually create another pipeline from that. We could also create a sync connection. And this is where stuff gets interesting, because this is where we tie back into the rest of the data ecosystem. So now we're looking at all the syncs that are available inside of Decodable. We could send this data to Pulsar. We could send this data to Red Panda or ClickHouse, S3. So for instance, maybe we want to write all of this data down to S3. Now, again, it's probably a bad example, because in the case of CDC data, keep in mind that we can actually output updates. And so systems like S3 actually don't know how to take update records. We could write the raw CDC events, but that might not be as interesting for analytics. Instead, we probably could write that data back to a system like Postgres or something like that, where we can deal with basically updates to records, or a system like Delta Lake, where we can sort of apply a series of updates. Anyway, that's just an example of how we can actually use this data to process, use Decodable and streaming SQL to be able to process change data capture data for a myriad of different use cases. You saw, an example of how you can build SQL on top of change data capture data, just like it was any table in Postgres or MySQL or any other system that speaks SQL, and how you can preview that in real time and see the results of those changes. CDC is incredibly powerful. You can build tons of really, really cool stuff, both for operational systems, but also for analytic systems. Hopefully this is interesting. I do encourage you to try this at home. You can sign up for the free tier of Decodable. Just go to decodable.co and click on, I actually show you. You go to decodable.co, and you can start free here and sign up and get started and try this for yourself with your own database instances or Kafka topics, Pulsar topics. There's a whole bunch of things that are supported today. Really appreciate the time. Do let us know if you have any questions. Join the community Slack, or just shoot us an email at support@decodable.co if you have any questions. Thanks for tuning in, and we'll talk to you all soon. Thanks.